Hi boys and girls, happy snow day, woo, yay! Hey, so I was thinking about all the talks that we've had about sand and erosion and weathering, and I thought it might be helpful for your upcoming tests if I sort of put them together in a little video for you. So here's a couple things I think that you should know. First of all, when we talk about rocks and sand and particles, it all comes from bigger, more massive rocks. It can come from mountains, it can come from landforms, but essentially what happens is those bigger rocks are broken down into smaller and smaller pieces. And when we break rock down, that's called weathering. So let's take a look at my first example. This is weathering. Weathering, if you look it has an EA in it. So does breaking down. When we say that weathering equals the breaking down of rocks, and they both have EA. That helps us remember weathering equals breaking down. So, how does that weathering happen? Well, oftentimes we get water that goes into cracks and then freezes, and then when it freezes, we know that it gets bigger and it helps the rocks to break apart. So when we have ice that gets in there and then it expands and it breaks the rock apart, that makes smaller pieces. We also know that we can have plants that can dig their roots down in the cracks of the rocks and force the rocks apart, making them to break down and become smaller. We also know that there's a process called chemical weathering. Chemical weathering is where we have some acids that form in our raindrops and they drop on limestone and they can make the limestone dissolve so that there's holes where the big rocks were and it's broken down into smaller rocks. So those are examples of weathering. We have ice that freezes and expands. We have plants whose roots get into the rocks and grow and push the rocks apart. And then we also have chemical weathering. And chemical weathering means, like I said, that we have tiny little bits of acid that drop down and help to dissolve the limestone. So those are just a few examples of weathering. Weathering happens over many years, and it means that the rocks are breaking down. So once we have the broken down rocks, what happens to them? Well, we have erosion. Erosion has an O in it, and erosion means movement. Movement also has an O. Erosion, O, movement, O. We've talked about a lot of different kinds of erosion and movement in the classroom. When we talk about it, we mean that it moves rocks and sediment from one place to another. Some examples of this might be if I took my rice right here, it's on a cooking tray. If I slightly held it up, we can see that we have erosion from gravity. It's sliding down on my tray. Okay, that's one example. We could also have erosion from wind, and I'll show you this up close. If we blow, you can see that the particles were moved by the wind. We also have erosion by water. If we pour water down on this, we can see that it will move because of the water. You can see that it's pushed it right out of the way. Another example of erosion that we might have is people. People will often make roads or cut holes in mountains, and when they do that, they have to push the rocks aside and move them. So that when we have movement of rocks or sand or sediment, that's called erosion. So I think that we understand erosion and weathering now. All right, boys and girls, how do we stop erosion? If we have a house that's up on top of a hill, we don't want it to slide down the hill because the soil and all the dirt has been eroded or moved away. So oftentimes we build fences. If we're a farmer, we might build steps into the hill so that we could farm there and our crops won't be eroded away. Those steps are called terraces. We can also build walls if we live by water so that the water does not come and take the soil away from our ground and our property. Here's a few examples of how we stop erosion. Here's a retaining wall. You can see that the wall was built so that the water cannot get to the property behind it. That helps to stop erosion. That kind of makes sense, doesn't it? Here's an example of the terraces going up on the hill. You can see that the farmer has planted them in steps going up the hill to help prevent erosion because we don't want that to all slide down. Again, that kind of makes sense, doesn't it? We understand that. So when we're talking about the size of sand, we learned that scientists said, well, hey, if we're talking about sand, how do we know what size it is? And so they decided that we had to have a certain size for it to be sand. And we used those small circles when we were studying, and we looked to see if it actually was sand. Scientists wanted to know, what is the size of the sand? So they decided that sand is going to be 0.06 millimeters all the way up to 2 millimeters. Now, 0.6 is tiny. It's very small, and 2 millimeters is still small. Scientists use millimeters to measure. When we write millimeters, we write mm. So the size of our sand is 0.06 all the way up to 2 millimeters. But we knew that, and I know that you are super scientists and you already got that one right. Well, what do we call particles that are too small to be called sand? If they're too small and they're so very fine and tiny, we call that silt with a T. If we have silk with a K, that's a fabric that we wear. So when it's tiny, tiny particles, we say that's silt. Good job. I know you're getting these right. If it's too big to be called sand and the particles are bigger than 2 millimeters, what do we call them? What do we call particles that are too big to be sand? I think so many of you know this one. You are right. Gravel. Ding, 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 ding. Yay, awesome. So, boys and girls, we've taken a look at weathering and erosion, the size of sand. I think you're going to do great on the test. I hope you have a wonderful snow day, and I'll see you tomorrow. Bye.